Group number, group A. Group A. So please come in front and please put the paper on the whiteboard using magnets. Okay, and then everybody has to listen all the presentation. Okay. So I think you have done a lot of brainstorming. Brainstorming is to connect the brain in your team. Now the presentation is to connect the brain to the other teams. Okay. So let's listen to the idea of the other team. Then you will get more idea starting from tomorrow. Okay. So it's very important to listen to the other team's presentation. Okay, so I will set alarm, 3 minutes alarm. Okay, so each team has to keep speaking for 3 minutes. Okay, so I will start the alarm. Okay, no silence. Okay, 3 minutes. Just a second. Just sorry. I don't know. Set was okay. Are you ready? Yes. Okay, please start.
Okay, hello, we are Team A, and our idea is to make sort of like an exoskeleton. So this is, as you can see, this is the finger here, and then we have an exoskeleton that's on top, and the soft material is supposed to go on top of it. So the idea is that it's going to expand more around where the joint is, so that's going to force, it's going to pop up, and then that's going to allow this joint to bend. So by pumping air in, pumping air in, and that's going to expand. So this is, the exoskeleton is going to be with PLA, so we're going to have to make this out first, and then make another mold outside, put the PLA in, and then inject this mold outside of that PLA, which is our via, and then just have to strap it up, and hopefully it works. But the problem will be that where to put the sensors, because according to the TA, the sensor only works upon contact. It does not, the current does not increase with pressure. So we're still wondering where we could put that. And we are also wondering, like I say, anything you want to add?
Here, so and we must leave a space here, and we want to avoid the skin and POA must be stick together.
Yeah, because around the joint, so if it sticks, like if the silk skin is injected like into the joints here, then it's not going to move. So we actually need like the patella of the knee has to be on top of it to avoid the silk skin from joining with the joint here, so it can still maneuver.
One more minute.
One more minute.
It's too long? Okay, one more minute. 45 seconds. Okay, somebody more.
Yeah, to add something
about
the sensors. So one idea would be to. We're not sure if there's other sensors. Maybe we can make it like a. You press a button and it. So you don't use a sensor to detect where you grab switch. You switch on by yourself, and then you grab, because we can't put it on a strap here. That's gonna be weird. Or maybe we can use something. Look at some unknown technology.
I can give you comments. Okay, let me remind you something.
Okay.
Our human skin is flexible, so when you bend, actually the total length elongates.
Yeah.
But if you have a solid part close to your finger, the length doesn't elongate if you have PLA designed like that.
Right.
So that would be an issue. So probably you need some flexible parts so it will loosen a little bit when you bend, tighten up when you go back to straight.
Right. Maybe the joint can have some give.
You need to figure out.
Okay.
Thank you.
That would be something you need to be aware of.
Springs.
Like a
Springs.
spring. Yeah, maybe. Yeah. But definitely you will see issues like that.
Okay.
Other comments?
Do you have any idea how to put to the joint? I mean, how to connect it for each index or each finger with about the joints. Yes. Yeah. Any idea to?
We're gonna
connect
use
each part?
pins. Yeah, that's the initial idea.
Oh, okay.
You definitely will be keep on trying
Okay.
different dimensions. Because the first design probably won't work. Then you know what to do.
Alright, okay.
So I have a comment from the viewpoint about project process. I like your figure very much because it shows not only the static mechanism, but also you show the movement.
Yeah.
So deformed shape. I think this helps the idea creation very much.
Okay.
So it's good enough. Static drawing is good enough, but sequential diagram really helps the idea generation.
Thank
So
you.
yeah, this is very good. Okay, that's it. Okay, thank you very much.
Thank you.
Okay, so group B. Very good presentation. Students can see the number. Okay, quick. Yeah, as you can see, 3 minutes is a relatively long time. Okay, so you have plenty of time. Okay, let's start.
Okay, and first, in everyone's eyes from here. First, we want to find the best way we can do very quickly and very fast. So we use our thumbs to control our robotics. So, and we found use our thumbs.
Mhm.
Your sensor will be more ergonomics, and then we find some way we can a step of design. First is we need to have a 3D print for mode. The material maybe is PLA, ABS, which can use we just use that. And sensor choose. We need to choose where the sensor put. Maybe it's here or here. Depends on what the maybe it's code, maybe it's the engineering design of our CAD or something, or manufacturing process, and the design for our circuit, and the mechanism design. And then we found experience from professor and TA. He said the pressure and the angle will have a relationship. So the design process that we found is we build a lot of mode and build a lot of robotics and use like maybe data log or something like this to find the relationship of the pressure and the angle. And the best result we found is a linear with pressure and angle. But I think it's impossible for the high
I don't care.
So that is why we made a lot of mode for try and error.
I will explain about it. Probably as a wide suite, so it can expand so much. So we expect it for one is better, and in addition, we will because it's like this and like a
Like a group.
yeah like a finger. So yeah, you need perspective.
Okay.
Okay. So,
Okay.
comments.
Some comments. Maybe your drawing is not clear enough. It's difficult for me to understand, but you have clear minds of what you plan to do, so which is good.
Mhm.
My suggestion is do not make too many molds at the beginning. Try one first, learn from the 1st
Mhm.
design, then
Mhm.
move on to the next.
Mhm.
Don't make 10 and then maybe all of them fail.
Mhm.
So start from step by step.
Any idea about the dimensions? Because dimension is also important when we have a design. So which finger are you going to choose? Like middle finger or ring finger, index finger, or how long we will be based on the size for the air chamber or the overall size?
We want to use first. We want to use thumbs to control the
Point finger.
point finger. So we will choose this one.
Oh, okay, sorry. And so I want to design for other fingers? No. No.
Not going to that part. Not yet.
Okay.
So I like your presentation very much because you have a plot. So you really learn engineering. So yes, always for communication, visualization really helps. So I say that drawing is good, and also plot or equation, whatever. Okay, any visualization method you have learned in university should be useful. Otherwise, yeah, and the university professor will not teach that. So please, yeah, keep using such a visualization in your project. Okay, thank you very much. Okay, so group C, A, B, C だね。C. Please come in front quickly. Okay, are you ready? Yes.
Okay.
Okay, research.
Okay, hello, now we are going to group C, and in our idea, we want to make our software more stronger, and this is our first idea. We let the value here more larger, and we think we can bend more payload. And this one, we need to change the square of the structure. And we think the same with the more value, we think the more value will be more angle can bend. And then
We still can't figure out where to put the sensor. Yes. The only one thing we may think is put
Fingertip.
fingertip to
Like that.
like that. Yeah, to measure the pressure on your finger, so you can hold it harder or easier. Yeah. So in case you drop the stuff. Yeah. And
I thought the rectangle, it has edge,
Yes.
and the edge makes more less stronger.
Okay.
Sorry. I thought easy to break, easy to
Okay.
so smooth shape can be more strong.
Okay.
I so we want to try.
One more minute.
okay.
Other things you have discussed?
Yeah.
Yeah. we have discussed 1 hour. So yes.
We also discuss the shape of on the top. Maybe we can use like this. Maybe we can use a shape like this. So when the air is here, then here's a lot of this. So it's bigger and bigger. So this will touch each other here, so we can bend more. Maybe yeah. That's the first. We didn't draw that.
10 seconds. Something. Final word. Final word.
Okay.
Okay, thank you.
I like the idea about smoother shapes, and you mentioned maybe it's because of the strength. I think it kind of makes sense because rounder structure tend to evenly distribute carry the load. So maybe you are right. I like when you say something with a possible reason. And when you mention about the stopping geometry, it also makes sense. Maybe the change of the geometries have a stop somewhere, so it allows greater information. Maybe. But try to visualize it so you can make CAD drawings. Okay, good.
What about the shape of the air chamber inside no matter for the rectangular soft robot or the smooth shape or the soft robot? What about the shape for the air chamber? For the rectangle one, it should be rectangle, right? But how about the smooth shape one? It's also like a smooth chamber or okay.
Yeah, really.
Okay. Okay. Quite cool. Okay. And we can test it. Yeah, I'm not sure if it works or not, but we can still try it.
Yes.
I like you started the drawing during the presentation. That was very good, very good. So compared to the other teams, the number of ideas was a bit small. The number was small, but you started drawing. So if you keep doing that during 10 days, you will have a lot of ideas. So it was very good. Okay, thank you very much.
Thank you.
D. Okay, group D, please come in front. Okay. This is putting it on the whiteboard. Okay, good. Okay, let's start.
First time, we think about why this is square.
Oh.
So we think we should try to trapezoid the stack. It is similar to Group C, but we think comparing is too important. So it should be keep cut off corner not shared. So we try to trapezoid the stack.
So we just think this kind of shape can concentrate the force more. And here give us a sample. Sample propose this part might be pop out. Might be dangerous. So we want to balance the two parts. Their information on these two parts. Balance. This part can be bent, and this part also can be bent more. There's some we follow the tips on the slide and just select something nice and also like a silicone rubber for our head.
One more minute.
One more minute. Oh, and there's our measurement. It's based on sample, and we adjust it a little bit because we has a trapezoid shape. So the sample here is maybe 8 or 7 millimeter, and because this we don't make it too thin like a triangle, so we said it's fine, and we said maybe 8 channels or totally long is 10.4 centimeters, and that's our ideally.
Okay.
Okay, thank you very
I
much.
think it's good that you have geometrical dimensions and close to practical device. And from here you can already see there are many variables. And in 2 weeks, it's impossible to try every combination. So you probably need to figure out which dimension is more important, more sensitive. So maybe slight change or large change will improve your design. So that would be an important part later on. Okay.
How about the sensor part? Did you mention the sensor one? Where are you going to? Which one are you going to use and where you plan to put it on?
Consider it as a file. And it is on the whole device is used to help the patient whose finger cannot be curved. So there is the pump here, and the air will go into the device, and then there will be force to the channels, and then to help the patient's finger to curve. So I think maybe we will not say sensors.
Okay.
That's very good. You measure the dimension, but as you now know, what I will say, more figures. Okay. Okay. So especially it's a presentation. So please draw very clear figure so that everybody will understand your idea. Okay. So thank you very much.
Group E.
Group E. Yes, please come in front. Are you ready? Okay, let's start.
Okay, hello guys. We're from Group E, and
Okay.
the finger that we choose to do the rehabilitation is thumb. Thumb is different from other fingers because it has the same degree of motion, which is 3. But instead of moving like this, it can also move sideways.
Oh.
So in this presentation, we're gonna present in 2 main parts: this kind of motion and this kind of motion sideways. So I'll pass the mic to.
And we decide to use the composite material to make our product. And the lower part is need to harder than the upper part. Like the material of lower part cannot be shortened, cannot be extended, but need to be curved. So the material of lower part is maybe like a tape measure, like a tape measure, and the material of upper part will become a silicone rubber. And we decide to put the pressure sensor in the bottom of the figure like this one and this one. Yep. and about why we decide to use the composite material to make our project is because we think it's more this decision is this will make our project more curved. The bend is become more curved than this.
This mechanic is the function which have moved sideways, and we put 10 parts to here. This is hard part, and this is soft part. And when we push the air in this part, we can move the sound sideways.
So just to add a little bit more to this part, the reason why I put like question mark here is because, as you can see, there might not be space over here because you need some space to move. But we can only have we can just use one side to push and make it come back to the same position. So that's why I put the question mark here. You might not do that. So next is the material we're going to use.
And for the bottom of the material, we use the iron ruler. Each main component is steel. It has strong mechanical properties, but we are still thinking about how to not injure patients' fingers. Maybe could be more thinner or other methods.
Okay, that's it. Okay, is the final word? Go, quickly.
Material, we use silicone rubber, which is flexible and soft. And as they say, we in order to move the thumb, so we have the hard part and soft part. So and the hard part it just makes harder than the soft part. So we use PDMS as a.
Okay, thank you very much.
So one suggestion, or this is my guess. I think the rigidity of the ruler and the soft material is varies a lot. So basically, the ruler is very strong. It's made by metal. So it's very possible that your soft metal cannot even push or bend the metal part. So maybe you need to find a way to weaken the metal, or try to find softer metal sheets, something like that. I like the idea to have sideways movements, which is the first group to mention that. And also, I like how you try to separate the task of presentation. Good.
Any idea about the control part? Like, are we going to control the elongate the elongation one, and how about the side moving one? Are they separated, or are you going to control them together?
They are separated.
They are separated.
Yes.
So we'll use different air pumps.
Yeah. So let's say we don't have this part. The air pump we're going to use. We have two air pumps. Yeah, to control the sideway and control the spinning motion.
Yeah, the presentation was very good because you show the entire structure of the presentation first, and gradually, each person explains. So it's very easy for us to listen. Okay? Good, very good presentation. Okay, thank you very much. Okay, okay, please come in front. Okay, it's working, so you don't need it. Okay, please start.
Hi, we are Group F, and we mainly discuss about the side view of subpan. And we discuss on each length and the density of the pins, and also the thickness of the bottom. And finally, we decided and not to change the length of this in this part. By the way, we changed the thickness of the bottom. So it causes more bending the tips of the finger because this part is more thicker compared with this part. So it is stronger than this part. So it makes more easier to bend this part.
2 more minutes.
Professor said that the air chamber can make a bubble, and the bubble cause the displacement. So at first we thought we can change the thickness of our feet, but it will maybe impact the bubble and cause the displacement. So we fix here, and we just maybe set as this as a vector, then maybe we can make a model and design it, and maybe change the thickness as a gradient. Okay.
1 minute left.
We have a lot of factors to consider. Maybe the cross-section area, like a circle, or maybe like a T-shape, or maybe like a triangle. And also from the top view, we also can design like a
rectangle.
Yeah, something like this. But we just want to make a model at first, and we to think about the next factor what we want to choose. 那我的目标是什么？是封在手指还是这比我去录？
You should
Speak in English.
Try to answer by yourself.
Okay. 30 seconds.
Not asking the questions. It's your presentation.
30 seconds. 20 seconds.
Try it. Try it.
Yeah. More words.
Try to say something. Oh, they have something.
Oh, something. Origami.
Okay, what's it called? Thumbs up.
Okay. So maybe, yeah, time is up. So we can discuss later.
Yeah.
Okay.
Okay. So time is up. I just have one question about your design. Now you have this slope. Then how does it look like when you put it on the finger? So that means when you put it on, the air channel is has a slope. Okay, it's interesting. I have no idea how it's gonna look like. I would like to see how it bends later on. Interesting idea.
Very good.
Is it just a ramp or is it like a curve? Or any angles along at the bottom part? Like, are you going to design like a curve? Or a body curve? Or only just a ramp with a specific angle?
Maybe just non-linear would be fine.
Linear will be fine. That will be a little difficult to draw the model, to draw the model with a non-linear curve. Yeah.
Maybe use Blender.
Nice.
Okay. Yeah, you can try it.
So in your presentation, you showed the side view. I think that was very good. But I think you need more information, like material, sensors. I think you have discussed a little bit more about it. So please visualize all the ideas you have discussed. And then you can see the overview of the project. And that will help for you to continue the project for 10 days. Okay, good luck.
Okay,
thank you very much. Okay, last, but not least, okay, group G.
It's okay.
Okay. Okay, we start.
Okay, so hey everyone, we are Group G, and sorry for being so messy here. Here's all of our brainstorming things. So I think I will start with our brainstorming from here. So one of our members says that there are so many spaces between the things here, right? It's something like this. And we come up with, oh, here's so much spaces. Maybe we can use some of these spaces. And so this is that maybe we can add something here. Okay, so and the next brainstorming thing is the cutting over here. Here's the cutting. We think that our purpose of doing the bending is to make as much deformation as possible. So if we make this kind of triangle things, we can probably make it easier to bend. Maybe we're not sure, but we come up with this idea. And the third idea is to do another shape, but not the rectangle. So I come up with the idea of doing trapezoid, something like this. So we can make the upper deformation to be bigger, and maybe thus pushes the trapezoid next to it maybe more, so we can make more deformation. So we combine these three ideas here, and we draw another ugly picture here. Okay, so like this is the air inlet, and the trapezoid is over here, and we think we should make it bigger so that the distance between these two trapezoids can be smaller, and thus maybe it can push further and thus cause more bending maybe. And the other thing is the rectangle over here between the trapezoids. So if we have this, maybe we can increase more bending, I'm not sure. And the other idea is here, the triangle. And if we have this, we can make the bending getting more easier with not so many forces. So yeah, that is our idea. Anything
20 seconds. 20 seconds.
20 seconds?
Yes.
Yeah, that's it. No.
The material.
Yeah, and the material we want to use is the silk skin, which is the TA shows us the example. Okay, so that's it. Thank you.
3 seconds. Okay, thank you very much.
Okay, great. Your drawing is not ugly. So
Yeah.
it's clear.
Be confident.
And it shows various ideas in many spots. I would love to see what's gonna happen, but I can tell you there's one challenge. In order to make a structure like this using the molding technique, it's gonna be very difficult. So we need to think about how you release the structure. That would be the challenge. Okay, true.
That is what I'm going to say. Because in this, the wire on the top and the narrow at the bottom, it was very difficult to get rid of the mold. Even though we can design the mold with the 3D printing because it's very flexible compared to the metal mold, but sometimes it's very difficult to get rid of the soft robot out of the mold. Although the material is soft, but it's still a little challenging.
Okay.
So, well, you may think about it, but you can still try to move out.
Yeah, I like the presentation. It's a lot of ideas. So it shows you have been so active. Yeah. So please keep doing this. Then I think you will get a very good result. Okay. Thank you very much. Okay. So the team has done. Yes, a final word from Professor.
Yeah. So great. It's good to see some ideas that I have never thought of.
Ah, very good.
Yeah. So. Continue to think about those. Think about your fingers. See if they are healthy or not, and see how soft robot can help you. I think we have a very successful first day. I look forward to our second day tomorrow. So let's give ourselves a big hand.
Okay, thank you.